So let's see who all are here, and I will just need to send a reminder to everybody that class has started. So I go here, say class has started. Okay. So we have Nihan, we have Vivan, we have Myra, we have Hiranya, we have Arihan, we have Lochita, we have Dikshita, we have Gitesh. And here in the classroom we have Advik and Arav. So I just sent a reminder. I see many of the kids are still missing. So we'll probably give 2 more minutes and then we'll start. But before we start, I wanted to kind of mention what are the topics that we're going to cover today. So, and for the kids who are in 6th grade, this is probably, by end of this week, we would have covered all the topics that you guys need to know for 6th grade. Whatever we have been doing for last 3 weeks now, that would cover the syllabus for 6th grade, and then from the next week we'll start the 7th grade and 8th grade concepts also. So whatever you guys have learned so far, that pretty much covers the concept that you guys need to know. But if there is anybody in 6th grade and if you have any particular doubt with your topic in your grade, let me know. Otherwise, I would assume that whatever I have taught, that is good enough. Okay. So let's see who all are here now. Okay. So fine. So in today's class, what we're going to cover is primarily around geometry, where we will focus on the concepts related to area, perimeter of different shapes, area of composite shapes, introduction to 3D shapes, and then talk about data analysis and financial literacy. All right?
I just had the financial literacy chapter.
Okay. All right. So now I think we should get started. So we have Sundara also in the class. So yeah, still few kids are missing, but let's start. So we're going to talk about area and perimeter of different shapes, and then we'll talk about data analysis, financial literacy, and introduction to 3D shapes. Okay. So first of all, what do we mean by area and perimeter? I'll ask this question to Arihan.
Perimeter is kind of like the outside of the shape, and the area is the inside of the shape.
Okay. Nihan, any different opinion? The same opinion.
Yeah, but I'll mostly say like for perimeter, I'll just say like the boundary.
Boundary, okay. How about the area?
The area is like the space or the square units inside of the shape.
Okay. Right. Now, if you guys look at my face, this takes more area than Arihan's face, right? My face is bigger. Arihan's face is smaller, right? So this is a very what do you call it? Very lame example, but that is how you relate. Anything that you say area is bigger or smaller, essentially what we mean is the space that it takes is more versus it taking less space. Now, when we talk about area and perimeter, we essentially talk about closed shapes. What are the examples of closed shapes? There are probably 15, 18 shapes. Let's see who all remembers the name of some of those. Closed shapes. And I'm going to give 2 examples only. Yeah, Advik.
Closed shapes. Triangle and square.
Triangles and square.
Circle, rectangle.
Circle, rectangle. Okay. On the screen. Myra, Lakshita, Nihan, Arihan. I need name of two closed shapes from each one of you. Quick, don't make me wait. Yep. Yeah, Rehan.
Septagon and an octagon.
Okay. Sanvita.
A pentagon and a hexagon.
Okay. Kitesh.
Triangle, rectangle.
Dikshita.
Polygon and a circle.
Okay. Nihan.
A hexagon and a heptagon.
Okay. All right. Any other shape, Myra? No.
A nonagon and a decagon.
Nanogon, decagon. Okay. Nihan.
Octagon.
Okay. All right. So we'll probably stop there. Now, Bhuvan has also joined. So Bhuvan, we just started 5 minutes ago, and we are talking about, or we are revising the concepts around area and perimeter of all the closed shapes, and then we'll go to building the understanding around 3D shapes. Okay. Now, so what I will do is I'll pick up shapes one by one and then put the formula for area and perimeter. I will not try proving those formulas right now because that might get a little overwhelming and we will not have enough time. We have covered that in the previous classes, and whenever anybody has any doubt about how that particular formula for the area is derived, don't hesitate to ping me on WhatsApp, not in the class, and then we'll pick up those shapes, okay, and then we'll explain that. Now, when we say talk about closed shapes, I will put them into 3 categories, okay. One is triangles, other is quadrilaterals, next one is general polygon, which is beyond quadrilaterals. So pentagon, hexagon, octagon, heptagon, heptagon, nanogon, decagon, everybody gone. Alright. So everybody gone after that. Alright. So let's every gone, whatever gone it is. Now coming back to serious business here. So when you look at triangles, quadrilaterals, polygon, any shape with any number of sides more than 4. Now we'll come to that later. Here when you talk about triangles, perimeter is nothing but, as you guys said, perimeter is nothing but the boundary of all the shapes. If I'm talking about triangle, I'll look at this boundary plus this boundary plus this boundary. If I'm talking about rectangle, I'll look at this length, this length, this length, this length. If I'm talking about a pentagon, I will look at this plus this plus this plus this plus this. Done. Yep. So that is perimeter. I'm not going into that. As long as you guys know what is that shape, what is the property of the shape, you would not have any problem finding out the perimeter. That's assumption for now. And only thing that you will need to recall is when you are dealing with a circle, how do you find out the perimeter? There is no side, there is nothing that you can measure. So this is where we will have one formula called 2 pi r, which helps you find out the perimeter. We will come to that. I'm not rushing for it. Now, so if you're talking about, so perimeter I'm not going to touch. That's what I was trying to say by making that one line statement. Now coming back to triangles and quadrilaterals. Let's start with triangles. Perimeter we are not touching. Add the 3 sides, that is a perimeter. No doubt, right? If I'm forcing you guys to believe something, let me know. Yeah? Alright. So we are only going to focus on the area of a triangle. What are the different types of triangles we have dealt with?
Isosceles.
Equilateral triangle, isosceles triangle, scalene triangle. Then we have right angle triangle. We have acute angle triangle, obtuse angle triangle. Yeah, there are 6 types of triangles that you guys would have heard maximum, right? Anything more or less? No? Okay. So my memory is still with me. I have not forgotten anything so far. That's good. Now, hey Ritika. So Ritika, today's class is dedicated for geometry alone. Okay. So that is how we've started with area and perimeter of all the closed shapes. We have started with triangles. We'll go to quadrilateral, then we'll talk about all the polygons, and then we will talk about introduction to 3D shapes. Yep.
Okay, sir.
Alright. So now I'll keep on poking you guys just to make sure that everybody is able to follow me, okay? If I am going slow or fast, let me know. So now, when we talk about triangles, we are not going to talk about perimeter as I said. Perimeter is nothing but the length of the boundary, and you know when you're talking about triangle, you're essentially talking about 3 sides. You just add the length of the 3 sides, that is a perimeter. As long as you know the property of this triangles, right? If I'm talking about equilateral triangle, what I'm talking about? I'm talking about 3 sides being the same. If somebody says side of an equilateral triangle is 6 centimeter, find out the perimeter. No big deal. You know that equilateral triangle has all the 3 sides same, and as soon as you got length of one side, you just multiply that by 3 because all your sides are same, correct? Hiranya, do you agree? Yeah. So knowing the property of a shape is very important. If somebody says, I have an isosceles triangle, length of this side is 10, find out the perimeter. I'm stuck, I cannot move because I know in case of isosceles triangle only 2 sides are same. So maximum I can assume this is 10. How about this guy? Without knowing the third side, there is no way I can find out the perimeter. If somebody says, I have an equilateral triangle and the length of side is 6 centimeter or 5 centimeter, then it's no big deal. Equilateral triangle is all sides same. So if this is 6, this will be 6, this will be 6. I have no problem. Yeah? So, otherwise, there is some information that you will get, and there will be some missing information that you have to be clear about. That okay, without this I cannot solve this. If somebody says, I have a scalene triangle, this side is 12 centimeter, find out the perimeter of this. Even my whole family sits together, I cannot find it out. Right? Because it's a scalene triangle. Scalene triangle's basic definition is all the sides are different. No matter how many people are trying to help me out, we cannot find it out. Yeah? That's what I meant by saying, even if my whole family sits, let's say me, Myra elder sister, my wife, my neighbor, everybody sits together, then also we cannot find the perimeter of this triangle. Because there is not enough information. So it's important for us to know that what are things that we need for calculating something. Do you guys agree? Now here I'm saying, for a triangle, perimeter part you will figure out. You'll count the length of all the sides, add them together, that's what it is. Now, area I'm saying, area of any triangle is nothing but half into base into height. Problem solved. Any triangle you pick up, as long as you know the base and the height. When I say height, meaning height from the top. This height, as long as you know this height, or drop a perpendicular from here to here. So you are taking this as a base from here to here and multiply that by height, you'll be able to find out the area. Whether it's a right angle triangle, acute angle triangle, obtuse angle triangle, isosceles triangle, equilateral triangle, doesn't matter. You need a base and a height. If you are looking at this triangle, doesn't matter. You need a base. If you take this as a base, this will be your height. If you take this as a base, from here to here, this will be your height. If you are taking this as a base, from here to here will be your height. If you are taking this as a base, then here to here, this will be your height. So you need a base and a height. Yeah.
Are we just finding the symmetrical lines?
What is that?
Are we just finding like the
Symmetrical lines? No. That I will part for now, because only thing that we need to be aware or we need to be careful about is, if I have a triangle and I have to find out the area of a triangle, it will be half into base into height. And there is no definition of base. You can choose your base. You can say, okay, this will be my base. And if you know this height from here to the top, you're done. If you don't know, if you know this height and you choose this as a base, congratulations. You'll get wrong answer. Yep.
So when I see length times base, why could it not be length times width? Because they're both same. Because it's half.
Where is width?
Because it's half.
Where is width?
The base.
Where is width? I'll repeat myself. I'm trying to force that concept. There's nothing called width in a triangle. If you ever go and tell somebody that this is my width of a triangle, you'll not be believed. Okay? So that's why, sorry if I'm sounding rude, but the fact is, it's very important for us to wrap our head around this fact that if I'm talking about a shape, if I'm talking about a circle, I will never say this is the height of a circle. Because that doesn't hold true with respect to a circle. If I'm looking at a triangle, if I say this is the radius of the triangle, I can only shake my head. Okay? Alright. Is everybody with me so far? Yeah? Only takeaway from what I've been blabbering for the last 5 minutes is, if you have a triangle, you can choose your base and your height, and that has to be relatable. If you are taking this base, you can only talk about this height. You cannot talk about this height or this height. The base and the corresponding height against the vertex opposite to this. You have the flexibility of choosing a base. So your question can be tweaked in different possible ways. They will say, okay, this is a triangle. Find out the area of the triangle. This is this side is 10 and this height is 8. We get tempted to think, oh, this is my base and I need the height. Don't worry. Flip this triangle 90 degrees and then visualize this. This is your base and this is your height. You're good. Yeah?
So for the perimeter for the triangles, for the isosceles, do you need 2 lengths, and for scaling, do you need all 3?
Yeah.
Okay.
So see, math is as dumb as a computer. It doesn't assume anything, okay? It's us as humans, we assume a lot of things. Beat computer programs, beat math. There's no space for assumption. It's written in stone. You need perimeter, you need this length, and this length. You have a straight answer for this? No. Are you able to derive it? No. Done. You cannot go forward. Your program has crashed. Abort. Yep. Let's move on. So we talked enough about the triangle, but I'm assuming that with all that repeated messaging around base and height, the only intent is that it's always the base and the height against the corresponding vertex, or the distance with the perpendicular distance between the base and the opposite vertex. So if this is my triangle, I'm talking about this as a base and this is my vertex and the perpendicular distance. As long as I know this and I know this, I can find it out. If I am talking about this as a base, the perpendicular distance. So this base and this height. So you guys can always choose your base and height. There is no side of a triangle which is confirmed or mentioned as a base. Okay? Yeah? Is everybody with me so far? At least 1 or 2 yes. Okay. I can see a nodding face. That's good. Alright. Yes, Hiranya is saying something? Somebody was raising hand. Gitesh, was that you? Okay. Alright. I'll move on now. Now comes the next shape. This is where we have a little more complexity in life. If you're talking about quadrilaterals, you're talking about a rectangle, you're talking about a square, you're talking about a rhombus, you're talking about a trapezoid, you're talking about a kite, you're talking about a parallelogram. Yeah? I think that's it. Yeah. Yeah. So you're talking about 6 shapes. I wish there was one formula for telling you what will be the area of a quadrilateral. Unfortunate fact is there is none. Now, let's look at them one by one. I hope nobody has any doubt about area of a rectangle being length times width. We'll not even spend time there unless somebody wants to. It's fine, right? Area of a rectangle is length times width. Now, when we go to square, I will assume that square is also like a rectangle. So area of a square is length times width. Interesting fact is square has all the sides same. So width is also same as length. So length times length.
So it'll be 4 times S, so the 4 sides together.
Why you are switching from area to perimeter? I'm talking about area right now.
Oh, I'm talking about the square's area, like length times length.
Yeah, so that's what it is. Yeah. Now comes, how about area of a rhombus? Who remembers or who can tell me what is the area of a rhombus?
It's like the 4 sides times the height. Oh no. What's the thing called that the giant line?
Okay. There is no time for debate here. I'm just trying to see who knows who versus who doesn't. Area of a rhombus. Who remembers how do you calculate the area of a rhombus? Yes, Ritika.
Wait, is it like where you like multiply like the diagonals and like divide it by
2. Yes, you're right. So I will just spend 1 minute to cover that. First of all, everybody should remember that rhombus is nothing but a squeezed form of a square. You had a square, you were, let's say this was my square, okay? I mean, you are seeing 2 sides of the square. And these are the 2 corners, the 2 vertex, where somebody applied or squeezed it. What happened? The square became taller. The length of my hand did not change, okay? My hands remained the same length. But instead of being wider, it became thinner and taller. So if you visualize this with a square, you have squeezed from these 2 places and these 2 got stretched. This became taller. So that's what you are seeing here. So you have this side are same. So that's what Ritika was saying. If you visualize this further, if you join the 2 opposite corners of a rhombus, the property that we need to know is that rhombus has all 4 sides same as square, but the angles are not 90 degrees. And then when you made a rhombus, meaning all your sides are same but angles are not 90 degrees, and when you join the opposite corners, these are called diagonals. Okay. Now if you look at this little carefully, this is one triangle, one right angle triangle, this is another right angle triangle, this is 3rd right angle triangle, and this is 4th right angle triangle. The area of this rhombus will be equal to this area plus this area plus this area plus this area. Four areas, area of these 4 right angle triangles. And interesting fact is that these 4 right angle triangles are exactly the same. Okay? They are congruent. That's what we have proved in one of the previous classes. But not trying to prove that here, just in the interest of time. So area of this rhombus is 4 times area of this, or one of the right angle triangle. So 4 times area of right angle triangle. So right angle triangle half into base into height. This is the base and this is my height because this is right angle triangle. Okay. So 4 into half. Now this base, other property of a rhombus is when the diagonals meet, they bisect each other perpendicularly. Meaning, if you have a rhombus like this, let's say if you have a rhombus, you blindly just join the opposite corners. What happens is, these are diagonals and the diagonals meet at 90 degrees. That's one of the properties of a rhombus, okay? And they bisect each other, meaning this is equal to this is equal to this. That is how I was telling you guys that for now you can assume, I can prove that again. I have proved this at least 5 times in the class before, and that's why I'm not trying to do it one more time. But if needed, we can do it in later class also. So the area of this rhombus is 4 times the area of one of the right angle triangles. And the area of this triangle is half into base into height. Again, base is this, which is half of one diagonal 1, and height is this, which is half of diagonal 2. So that is how Ritika was saying that area of the rhombus is diagonal 1 multiplied by diagonal 2 divided by 2.
Is
Pythagorean theorem.
Is it in play in this one?
No, Pythagorean theorem has not come into play so far, so don't worry about it.
Okay.
It's only about the property. So as long as you know that if you are dealing with a rhombus is nothing but a squeezed form of a square, and the certain properties of rhombus is that when you have a rhombus and you join the opposite corners, these are called diagonals, and the diagonals meet each other at 90 degree. They make 90 degree angles and they bisect each other. Meaning any rhombus, if you pick up blindly and join the opposite corners, you will see that they meet at 90 degree and this side is equal to this side is equal to this side. Yep.
So the formula is just d1 times d2 all
By
by 2.
2. Yeah.
That's it?
Yeah. So that is how area of a rhombus is d1 into d2 by 2. Everybody with me? Same thing. Now let's move on. So I talked about quadrilaterals, we talked about rectangle is done, square is done, rhombus is done. Now let's look at another shape called kite. Who knows the area of a kite? Yes, Vivan.
Area equals PQ over 2.
PQ over 2. What is P and what is Q?
Look at the diagonals.
These are diagonals. So same thing applies here also. If you are looking at a kite is little different from a rhombus. In case of rhombus, all your sides were the same. So this side were same. But in case of kite, that is not the case. Only the above two sides are same and the below two sides are same. Okay? And when you join these two, only thing that you can take away as a property is, in case of a kite, the diagonals meet at 90 degree. Okay? They meet at 90 degree. And they don't they meet at 90 degree, but they don't, I would not say they bisect each other, okay? Because this will be not equal to this, okay? This will be equal to this, but they just meet at 90 degrees. As long as you remember that part, that should help you figure it out. So what happens is, the area of this kite would be equal to area of this plus area of this, and area of this plus area of this. Okay? And what happens is, when you look at the theorem for congruence, when you apply the theorem of congruence, you will figure out that this triangle and this triangle are congruent, this triangle and this triangle are congruent. Yeah?
So you at least have to give two sides and one diagonal.
Both are called diagonal only. Only difference between these pair of diagonals and this pair of diagonals is, here the diagonals meet at 90 degree, here also the diagonals are meeting at 90 degree. In this case, the diagonals are bisecting each other, meaning they are dividing each other into equal halves. Here it does not.
So what's the formula?
But, so here the formula is same thing. Diagonal 1 into diagonal 2 divided by 2. And that will become the formula, but I'm not trying to prove it now. We have proved it before, okay? And if anybody is curious, let me know. I will prove it in the next class, okay? But simple thing for you guys. See, again, my job is to simplify this for you, right? So I'm saying that if you're talking about the area of a triangle, regardless of what type of triangle you're talking about, it's always half into base into height. Figure out your base, find out the height, done. If you're talking about quadrilaterals, rectangle and square you can relate, you're good. Rhombus and kite, they are relatable. They are relatable. So, this is how you get the area for this. And I can prove that if you guys want it, but I need 15 minutes for proving it. I'm just trying to be a little sensitive about the time. I'm not proving it right now, but the day you feel like proving, the day you want me to prove it again, I'll do it happily. Okay? You can do it tomorrow if you want. Is everybody with me so far? So rhombus and kite, similar shapes, and area formula is also same. Does it make sense, Ritika? Vivan? Yeah? Alright. Now let's go to the next shape, which is called parallelogram. Parallelogram also I will give you guys a little bit of those. Area of parallelogram is nothing but base into height. Now you will say, why it is base into height? So this is the base and the height is the distance between the parallel lines. Okay? Wait, be complete. Now you will say why it is base into height. Now look at this. If you explore your visualization skill a little bit more. Let's say this was my parallelogram A, B, C and D. What happens in case of parallelogram? The opposite sides are parallel and equal. So this side and this side are parallel. This side and this side are parallel and equal. If you think a little bit more, what did I do? From this point and this point, I have dropped a perpendicular line on the opposite side. Now you look at, I will say this is E and this is F. If you look at A, E, F, D, this is nothing but a rectangle, isn't it? Yeah? I am saying between my original parallelogram and the rectangle, what is the difference?
It takes a piece and replaces it.
Yeah, it's a plug and play kind of a thing. If you're looking at a rectangle, which I am getting by drawing the perpendicular line, and my original parallelogram,
It's now gone.
see, when you're looking at parallelogram, you will discount the green part. When you're looking at the rectangle, you will discount the blue part, isn't it?
So it's technically a slanted.
So, if my parallelogram and the rectangle have the same area, my green part and the blue part have to be same. If they are same, we are good. And interesting fact is they are actually same, because these two are parallel lines. So this length and this length are same. And we already know parallelogram, this side and this side are parallel and equal. So this side and this side also same. Okay? And this angle is 90 degree, this angle is 90 degree. So these two are right angle triangles, and there is a theorem for congruence for right angle triangle, which says the two right angle triangles will be same if their hypotenuse is same and one of the sides are same. So actually the blue and green triangles are congruent. They are exactly the same. They have the same area. They have exactly matching properties. So that means whatever I did to make a rectangle, that has same area as this parallelogram. Now what is the area of this rectangle? This is the length this is same as this one. So this length times this height. Length times width. This is the length, this is the width. Here I am not saying width, I am saying it a height. That's the difference. So that is how area of a parallelogram is base times height. Is it making sense?
Yeah.
Now?
So we're taking
Yes, sir.
and replacing.
Yeah?
Yeah.
Yeah? Myra? Myra, did it make sense?
Yes, sir.
Okay. Alright. So basically, from this we figured out that area of a parallelogram is base times height. Now, if you guys recall, area of a triangle was half into base into height. The area of parallelogram is 2 times of that, basically. Or if you want to still get some more visual dope on this one, this is your parallelogram. The area of the parallelogram will be base into height, base into this height, and area of a triangle will be if I look at this parallelogram and draw these opposite corners, I see there are two triangles, and every triangle will be same, which will be half into base into height. Look at this triangle, base into height. Look at this triangle, base into height. This height, which are same. So basically, area of parallelogram is 2 times the area of a triangle, or vice versa. Any which way, if you want to visualize it that way. Lakshita, Gitesh, you guys have been very quiet today. Are you able to follow me so far?
Yeah, technically yes.
Sandrita, Hiranya, both of you fine? Okay. Bhuvan, are you with me? Vasundhara as well? Yeah. No, so again, that is my duty. That's why I keep on asking you guys, okay? Because if there's smallest of a doubt,
You must fix it.
you have to let me know. Now, yes, Gitesh,
My videos aren't working. Can I restart my computer?
that's the only way to fix it. So every time when you cannot hear me or cannot see it, the only way it works is disconnect and join. Yep.
No, I see your screen and I can hear you, but my
No, your video not working is fine. I mean, as long as the purpose is met, you can see me, you can see the board, and as long as you can follow me, okay, you should be fine. Yep. See, only few of the kids have turned on their video, and I'm happy about it. I would love to see all of you on video, but if some of you are not able to come on video, it's fine. That's okay. Now, coming to the last shape among the quadrilaterals, trapezoid. Let's see who remembers the formula for the area of a trapezoid. Let's see. Let me check with the new kids. So Ritika, Hiranya, do you guys remember? And again, I'm not trying to put you guys on the spot. I'm just trying to see. Yeah, Ritika.
I think it's like where you like add both of the bases and then you like divide it by 2 and then you multiply it by the height.
Half into 2 bases meaning 2 parallel sides, right?
Yeah.
Okay. Multiplied by
The height.
height or the parallel distance between the parallel lines, right?
Yeah.
Sanrita, is that your understanding to it?
Good job.
Yes.
Wonderful. So see again, my request to you guys is don't be shy. And I saw something that Advik did just now. He said, good job. So he's praising friends. And there's no harm in doing so. Okay. So when you hear something, when you're happy about somebody explaining things, express it. That's fine. Yeah, Vivan. Yeah, go ahead.
Oh, I forgot to put it down on mine.
Okay, no problem. Pranav, are you clear, beta?
Yeah, I forgot to put it down.
Okay, not a problem. So, same thing. So, when you talk about a trapezoid, area of a trapezoid is half into sum of parallel lines multiplied by the distance between the parallel lines. That will be the English part of the formula. So, area of a trapezoid is half into sum of the parallel lines multiplied by the height. Now you'll say, looks like interesting formula, but what? So I will again just give you guys a quick rundown of how this is arrived, how it is derived, so that tomorrow if you get tempted to prove it yourself to be convinced or be more convinced, you can do it yourself. Look at this. This is a trapezoid. What is the property of a trapezoid? In case of a trapezoid, only one pair of lines are parallel. Remember, there are only one pair of lines parallel to each other. If you have two pair of lines parallel, that is not a trapezoid.
It is a parallel.
Only condition that we have to agree to is, in case of a trapezoid, only one pair of lines are parallel to each other. Nobody ever said that they are equal also. We are just saying they are parallel. Okay. So now they are parallel, meaning this and this are parallel. I am saying parallel, so let me put parallel symbol. I am not saying they are equal. Okay. This looks smaller, this looks bigger. Now, how this formula is derived is by doing this. If I drop a perpendicular from here to here and from here to here, now if you visualize this shape, this is made of 3 components. this green triangle,
of the blue triangle.
then this blue rectangle, and then this other green. I'll not say green, I'll use a different color.
Light green.
I will use a purple. There are so many girls in the class and they like purple,
That's
right?
pink.
Okay. So that's pink. Anyway, so now this is made of three shapes, two right angle triangles and this rectangle. Once we add the area of all these three shapes, that is how you get the. See, we said half into base, into height multiplied by sum of two parallel lines, A plus B. Now look at this. This is parallel line. This is A. Here to here is A, and this plus this together
Is B.
will make it B. So if you look at it carefully, what will happen is when you find out the area of this guy, it will be A times the height, and this will be this plus this into this by 2. That put together, that gives you the formula. I'm not trying to prove it. Just get your hands dirty, try proving it if you want to be more confident about this formula. Anybody have any doubt? Yes, Pranav.
But my teacher said you can also do 1 by 2 times A plus B into height.
Same thing. Height is nothing but here the distance between the parallel lines. Same thing. You can call it height. You can call it the distance between the parallel lines. Both are same. Yeah.
Okay.
Can you look at it like as two rectangles?
No, you cannot.
Okay.
Because see, you can look at it like rectangles only if it is symmetric.
Oh.
This is also a trapezoid. Can you look at like two rectangles now? Now, right? No, I'm just telling you. See, any formula that you arrive at, that has to be generic enough that can apply in all circumstances. This is outlier.
Okay.
Yeah, Gitesh.
Can you explain one more time?
So again, this one I have proved at least 3-4 times. So I'm not trying to prove it just in the interest of time for everybody else. But simple thing is this, okay? Trapezoid, you know, trapezoid is a quadrilateral, meaning a shape with 4 sides, where only one pair of lines are parallel, meaning this line and this line are parallel, okay? And I never said that they are equal also, they are just parallel, okay? So if you have to find out the area of this trapezoid, it has to be 3 things together. You have to find out the area of this right angle triangle. What did I do? I have dropped a perpendicular from here on this line. So this is 90 degree. Similarly, from this point I have dropped a perpendicular. This is 90 degree. Okay. So area of this whole trapezoid will be this area plus this rectangle's area, and then this right angle triangle's area. Yeah. Now look at this. This is A. When I dropped a perpendicular, this is also A, and this, let's say this is X, and this is, let's say, Y, and here to here is H, height, or the distance between the parallel lines. So here in this case, you will have to find out the area of this right angle triangle, which will be, let's say, half into X into this height H, plus this rectangle, which is length times width. Again, width is nothing but height, so A times H, plus this triangle's height, area, half into Y is your base and your H is your height. From this, when you add all this together, this is the formula that you will get. How you will get, I'm not doing it right now. I want you to try this. Yeah? Yeah?
Yeah, I understand.
Okay. All right. So we looked at all the different shapes which are with 3 sides. How to find out the area and perimeter of those. And we looked at all the quadrilaterals. Okay, so where we look at the area and perimeter of rectangle, square, rhombus, trapezoid, kite, and parallelogram. So let's do one. So here, unknowingly, we touched upon a concept called composite shapes. This became a composite shape actually. Now, what do you mean by composite shape? When a shape is, you guys know what is a prime number, right?
Yeah.
Do you guys know what is a composite number also?
Yeah.
Yes.
And number that can be
I will know what
Okay, no, don't give me a lecture. Tell me yes or no. You know or don't know.
Yeah.
Prime number cannot be divided into multiple fractions or factors. Composite number can be, right? So that is the difference here. Interesting. I used a marker which I cannot erase. So this pink has become permanent color on this board. Anyways, coming back to the important, relevant thing. So we touched upon a concept called composite shape. Like I was giving you guys a comparison between a prime number and a composite number. 2 is a prime number because you can only write this as 1 into 2. What is a composite number? 4. I can write this as 1 into 4 or 2 into 2. Similarly, 6 I can write as 1 into 6 or 2 into 3. When you have more than one factors, apart from the number itself and 1, this is called prime number. This is called composite number. When you have more factors apart from itself and 1, that is a composite number. Same thing applies for a composite shape. Meaning, when the shape is made of multiple things, you have multiple factors here, then you have multiple shapes. So we will keep on learning about triangles, rectangles, kites, squares, whatnot. And you will end up learning formula, memorizing it. Put your hands down, I'll come to you. But life gets more interesting if somebody says, find out the area of this guy. How will you do it? You want to go to a restroom? What is the question?
No, just question.
No, then the question have to be part. We don't have enough time right now. Now, if somebody says find out the area of this shape, there is not even a single mathematician in the world who can dare to find out the area of this shape or anything like this. There is no defined shape. This is a closed shape. But how do you find the area of this guy?
Octagon.
Hopeless gone. This will not do anything. I gave a bad joke, but I'm saying this, you cannot see octagon, those are still symmetric shapes. This is a useless shape that you cannot relate to any scientific name also. I am just making it up. But what I'm saying is, any complex shape like this, you will not have a formula for this. So what you have to do is, you have to break it down into simpler shapes.
Then you have to mark points of the different shapes.
Join the corners. I did not mean to keep it like a curve, it was a straight line. Okay? Join the vertex. And now you see, you have all triangles. Find out the area of this triangle. We know the formula for this. If you have details, this is the other triangle, this is another triangle. Let's say this was a, let's say, trapezoid. Find the area of this trapezoid and this triangle. Add them all together. That's your area of the composite shape. So when we were trying to find out the area for trapezoid, we found that we could break it down into a rectangle and 2 right angle triangles and added them together. That gives us the area. So likewise, you might have a situation, you might come across a problem where you will have a shape which is so very unique in itself, and you cannot relate it to one of the basic shapes that we have learned about so far. But you can always break it down to smaller, simpler shapes and find out the area of those individual shapes, add them together. That becomes your area of the composite shape. Is everybody with me?
I remember my question.
Yeah.
Aren't like the composable shapes
Yes.
also known as 2D shapes?
Every shape is 2D shapes only.
Okay.
Happy? Don't be. Alright. So coming back to, so we talked about composite shapes, and there came a parallel thought. So we'll come to the the polygons later. And again, polygons, we actually touched upon that. So when I was talking about composite shapes, let's say if you talk about a Okay?
With this poly, is the prefix for many?
Yes.
It did not change between yesterday and today. It was the same day for yesterday also. So poly will not change from many to anything else. So whenever you have poly, polymorphism, polygon, polynomial, everything, poly stands for many when you're dealing with multiple things. Okay? So anyways, coming back to this one. So hold it there. Now in polygon, I'm just picking up one example, pentagon. Do you guys want to learn what is the formula for finding the area of a pentagon?
No. Yeah, I thought you know sort of.
Okay. Cut unproductive things as soon as you can. Coming back to this one. What I meant was, whatever we learned with respect to composite shape, same thing you can apply here. Now, I'm tired of memorizing formulas. I don't want to memorize any further. So, whatever I have learned, can I apply that for new things that I'm coming across?
Yeah.
Probably yes. Here, if I join these two, I have a right angle, I have a triangle here, I have a rectangle here. I'll find out the area of this triangle and the area of this rectangle, add them together, done.
It looks like a house.
Why do I have to worry about finding out a new formula and then breaking my head with memorizing that formula? Is there anyone in the class who knows the formula for area of a pentagon by any chance? Anybody? Ritika? No? Yeah, Vivan.
Sure, I'm pretty sure it's when you have to like add all of the points from the center.
There's no center.
I think you have to break
I
it.
like the okay now.
You have to break it apart into triangles.
That's what. So now I'm just curious that is there a formula for finding the area of a pentagon? And even if let's say by God's grace you learned it, wonderful. Now your life is getting more complicated.
Wow.
Does anybody in the world know what is the area of a hexagon?
That's a gem.
Doesn't matter, it's a hexagon. Split it in half.
Split it into two triangles.
Ritika, Lokshita, I'm trying to put you guys on the spot.
And then.
Have you heard about any formula for area of a hexagon?
No.
No.
No? How about you, Ritika?
I'm not sure. I don't know.
Okay, how about you, Salvita?
I'm not sure, but isn't it like a side squared times the square root of 3 times 3 divided by 2?
See, my life is already so very complicated and you made it more complicated now.
I know the area for a hexagon. It's base.
Okay, hold it there. Message is very clear. No point wasting time on things that you see. There are probably 200 times, I think. This will be 205th or 208 times, if I'm being conservative. Okay. So when I said 208 times, right? If I have to tell you guys the same thing so many times to make you understand one basic thing, that is not fun. That is not productive either. Okay, coming back to this one. So what I was trying to say was, if you memorize, you learn the area for a pentagon, hexagon, heptagon, octagon. I can only salute you guys, but I don't see a strong reason for memorizing it. If you memorize it, there's no harm. Learning new things doesn't do any harm. Only problem is you'll have more things to memorize. So my only suggestion is memorize it, but keep the concept also with you. So tomorrow if you come across a hexagon like me, where your memory is not there to support you with the formula, you will always look at breaking it down into simpler shapes. Area of rectangle I will not forget. Area of triangle also I will not probably forget. It's already been 48 plus years for me now, and I have not forgotten yet. So there is a hope that till I retire I will remember these two formulas. So till the age of 60 I am good. After that I don't know. For you guys also it will hold true. So these are basic shapes. You can apply it. On a serious note, you can always look at breaking it down and then adding the area. Yeah, Pranav.
Oh, nothing. I forgot to lower my hand.
Okay, that's okay. So the message here is if you're talking about any complex shape or composite shape, if you remember the formula for finding the area, wonderful. If not, break it down into simpler shapes. Now, I will just give you guys a jump start with respect to 3D shapes, and then I'll let you guys go. Okay? So, what do we mean by 3D shapes? So, okay, hands down. We have only 5 minutes. In fact, only 4 minutes. I'll cover the concepts quickly. Now, when you look at things along the x and y axis, or if you look at the board, you're only seeing a horizontal plane and a horizontal axis and a vertical axis, which is making this plane. So there are only two dimensions. One dimension is in the x direction, one dimension is in the y direction. If I draw a circle, let's say it is made of 10 points, everything is along x or y axis. That's it. X and y axis, nothing else. But if I stand on this one and you have to draw me, you cannot draw me on a board with 2 dimensions. You can visualize me, and if you guys are great with your drawing skills, you can do it, but that will still be 2-dimensional thing. It doesn't have 3rd dimension, meaning you have length. Let's say if I call this as length and this as width, there is no height into it. So we are talking with respect to x and y axis. There are 2 dimensions in the horizontal direction, the vertical direction. That's why it's called 2-dimensional. So all the shapes that we have talked about, these are called 2D shapes. Be it a circle, rectangle, triangle, trapezoid, hexagon, octagon, nanogon, whatever gon. These are 2-dimensional shapes. Now, if you look at this is a rectangle from this side. Now you know what I use this for, right?
Erasing stuff.
So this has length and width, and now if you look at this carefully, this has some height also. So x and y will not be enough. I need a 3rd dimension which defines the height. If you visualize this board being protruded towards you guys, that is the 3rd dimension. So length, width, and then the height. Look, visualize this pen on the board. Right now, this is only probably a circle that you are seeing from here. But if you look at from the bottom, you will see that okay, it's length, width, and then the height. So that is the 3rd dimension. So now some examples to really look at very quickly after unlocking my screen is that if you look at a circle and put circle after circle after circle after circle, or look at this notebook. This was a rectangle before, and then somebody stacked so many pages one after another. That is how it became
A book.
a book. So this is 208 times.
Wait, I didn't really touch.
You should keep a number on the board.
Okay, don't provoke me for doing something that I cannot stop doing. Now, here I have a rectangle. I added a 3rd dimension. This might be looking like a matchbox, if you guys know what it is.
Ice cube or loaf of bread.
Okay. So there is a 3rd dimension. This is called cuboid.
What's the difference? Not bad.
A 3D shape is just a bunch of 2D.
So you have a rectangle before, you added height to it, it became a cuboid. Look at a square. You add height to it, it became a cube. So the ice cubes that we deal with, it has certain length, width, and height, and we'll talk about the property of these shapes in the subsequent class. You have a circle. You had a circle. You added so many circles one after another. It became a cylinder, right? So this is where all the simple shapes that we looked at, that is kind of going to a 3rd dimension, or adding height to it, and that is how we deal with shapes like cube, cuboid, cylinder. We'll talk about cones, right? These are called the 3D shapes, where apart from something being measured around the horizontal and vertical axis, you have a third dimension also, which demonstrates the height, and that is where it becomes a 3D shape. So you guys would have heard a lot about 3D printing, right? We have always been printing on using printer. You put a paper, it prints something and you get it out. But it is just a piece of paper. It has only length and width. 3D printing is where you will see that somebody prints objects like this. They'll say, okay, I'm doing printer for making a pen. So because it's printing the height part of also things also. So that's where it's just a jump start with respect to what is a 3D shape, and we will get deeper into it. We'll talk about what comes into play. We have heard about area and perimeter so far. What happens, what changes for 3D shapes, what is volume, what is surface area, and all those stuff we'll talk about and try relating that with all the concepts we have learned so far. Any questions before I let you guys go? No questions? Already tired? Dikshita is already tired of me. Sanvita, are you tired as well, beta? No?
No.
No, okay. No, but I hope we learned something, at least we are able to relate. And a lot of things that you guys would be knowing already. We are just doing a recap of those also, so that what we learned, we don't forget. Ritika, Lakshita, everybody with me? Yeah. Okay. Alright, so I'll let you guys go. Have fun. See you guys tomorrow, same time.
Also,
Bye bye. Bye bye. Bye bye.
Bye, sir.
Bye bye.
Yes, sir, man. What does 2D mean?
2 dimensions. Length and width.
It isn't